A modern automotive assembly line moves to a relentless rhythm, firing thousands of structural joints in a continuous automated sequence. In a traditional steel car body, there are roughly 4,000 to 5,000 resistant spot welds. Moving along a body and white line, a coordinated grid of hundreds of robotic arms can execute each individual weld in under 6 seconds. For over a century, this highly efficient joining method has served as the universal standard and the invisible backbone of the automotive industry. Yet the most repeated manufacturing decision in history is currently being retired across the industry. The spot weld acted as a universal physical constraint. It silently pre-edited every car body, dictating the shape of the vehicle before a single sketch was ever costed. A resistant spot weld works by passing a heavy electrical current through overlapping metal sheets until they melt and fuse into a single point. This trick requires strict conditions. It only bonds cleanly and reliably when applied to identical or highly similar metals. The intense light weighting required by modern electric vehicle programs demands multi-material bodies. Manufacturers are forced to mix high-strength steel with heavy aluminum castings and composite panels. Attempting to pass an electrical current to weld aluminum directly to steel results in immediate metallurgical failure. The mismatched metals grow brittle iron-aluminum intermetallic compounds. The resulting seam is structurally engineered to crack under pressure. The industry's push for lightweight efficiency required an overhaul of the vehicle's propulsion. In the process, it broke the century-old physics of how a car body is held together. To bypass this metallurgical wall, the automotive industry spent a decade quietly building a second, highly specialized toolbox. They developed mechanical fasteners, including self-piercing rivets and flow drill screws, to physically bind the similar materials by force rather than heat. They scaled up the use of structural adhesives. Heavy-duty chemical bonds are now required to continuously join the long seams that spot guns used to tackle point by point. For flawless aluminum connections, the industry relies on a complex solid-state method called refill friction stir spot welding. Friction stir applies extreme localized pressure to soften two aluminum sheets, stirring them together below their melting point to create a seamless connection. A modern multi-material car relies on a complex, highly specialized committee of joining techniques operating simultaneously on the assembly line. Retiring the spot weld incurs a strict geometry tax. Every alternative joining method demands specific physical space, heavily restricting the shapes a designer is allowed to draw. A self-piercing rivet requires a wide flange to seat properly, and machines need access from both sides to press it in. Conversely, a flow drill screw utilizes single-sided access, making it the only fastener capable of sealing an enclosed aluminum box section. Structural adhesives demand wide, continuous bond lines and reject tight radii. Friction stir welding requires perfectly flat, easily accessible surfaces to function. By retiring the single, universal rule of the spot weld, the industry inherited dozens of narrower rules. Each joint carries specific spatial constraints that strictly dictate the vehicle's geometry. These hidden engineering constraints directly influence the stylistic choices made in the design studio. When a designer draws a knife-edge shut line or a flush wheel arch spanning two different materials, they're making a highly complex request about multi-material joining. In the old workflow, that joining question was answered months later by a manufacturing engineer. Once the spatial reality of the new fasteners is calculated, the surface design is already frozen, and the complex curves are rejected. To prevent compromised surfaces, concept phase intelligence is now a necessity. The specific choice of joints must be decided and pressure tested across real material transitions before the initial form is locked. The historical question in the studio was always, can the line weld this? Now they must ask what this new committee permits. The spot weld has been replaced by a highly specific ecosystem of bonds and rivets, meaning the mechanical decisions of the factory now definitively write the visible language of car design.